So I am doing my presentation on what evidence do we have that ice ages have occurred. The aim of this presentation is to show evidence and to summarise that ice ages have in fact occurred over the lifespan of this planet. And the three objectives are to show the physical evidence that ice ages have occurred, to show the chemical evidence ice ages have occurred, and to show that ice covering the planet has lasted a significant amount of time. The physical evidence for ice ages is perhaps the largest and most detailed evidence we have. There are many different physical pieces of evidence that can be used to show proof that glaciers have been on the planet and have shaped a lot of the landscapes with their power. My first piece of physical evidence is erratics, shown on your screen now. Erratics are large boulders that have been carried a long way, which cannot have been performed by any other transportation method, such as aerial or water transportation. Therefore, these boulders would have been carried by glaciers, showing the movement of them across the world. In the figure, as you can see, the grey things are the erratics, the big grey rocks, and they must have been carried quite a way to be placed because they're very out of place. This is in the Beartooth Mountains in Montana as well. Another piece of physical evidence to show the size of the glaciers that have been on the planet are corries or cirques. Corries are defined as a round hollow in the side of a mountain by the action of a glacier, as you can see in this picture, which is pretty obvious. A corrie starts off with a little nervation hollow, which forms from freeze-thaw and is then broken down by other processes from the glacier going over it, such as frost shattering, abrasion, freeze-thaw, plucking, and these deepen the hollow. This hollow then gets a lip at the end of it, from where all the erosion stops pushing forward and is pushed back into the cliff, which turns into a back wall. This glacier will then sit still and melt, and fill the hollow with glacial melt, which turns to a lake or tarn. The lip can then be emphasized by moraine deposited by the glacier. And that is shown in this picture here, where you can see the tarn, the back wall, the lip, which is all formed by the glacier. Moving on to chemical evidence, which are ice cores, and ice cores are a way of giving evidence that ice ages have occurred for a geological period, rather than like physical evidence just showing that there was ice on the planet. Ice cores allow us to measure the accumulation, chemistry, and the air temperature from past climates. This data can be compared to today's data, which means we can compare the different climates and concentrations of greenhouse gases. We can use this to see the ice lasted a significant amount of time. If we want to reconstruct past air temperatures from the ice cores, we need the age of the ice. Fortunately, the ice cores preserve annual layers, making it simple to date the ice. The seasonal differences in snow properties create the layers. Unfortunately, as you go down the ice core, the annual layers become harder to see. But there are other ways of dating ice cores, which include geochemistry, layers of ash or tephra, the electrical conductivity, and using numerical flow models to understand the age-depth relationship. The example of the ice core shows the different layers, different seasonal layers. The lighter ones represent the summer atmosphere and the darker ones represent the winter atmosphere. We can also use ice cores to show us the melt layers, which are related to summer temperatures and not related to bubbles of gas. The melt layers occur when surface snow melts, allowing water to percolate down through the snowpack. They form ice layers in the ice cores where there are no bubbles visible. The more melt layers mean the warmer the temperatures due to the ice melting or the snow melting, and therefore the less of them means the colder the air temperature. These can show a lack of melting during some months, which could show a low air temperature in that period of time, showing there could be an ice age after it's been dated. And this picture just shows what a melt layer looks like. You can also use ice cores to figure out past air climates. This is due to the concentration of greenhouse gases such as carbon dioxide and methane that have been preserved in the ice. We use two stable oxygen isotopes which are found in ice, which are 18 oxygen and 16 oxygen. And these, as well as hydrogen, are trapped in the ice from precipitation and therefore are trapped in the ice cores. The stable isotopes are measured in the ice cores with a mass spectrometer, which shows the change in concentrations of the isotopes through time, and this shows a detailed record of the temperature change. The figure above shows the change in ice temperatures during the last several interglacial glacial periods, and is a comparison to global ice volume. The local temperature changes from two sites in Antarctica, which are the top two, are derived from the deuterium isotopic measurements. The bottom plot here shows the global ice volume, which is derived from the 18 oxygen isotope measurements on marine microfossils. This graph shows that in the last glacial cycles, the ice volume increase and decrease a lot, but there are points at which the ice volume is high and shows that there is a lot of ice on our planet which lasted for a significant amount of time. You can see here where the temperatures are high and the global ice volume is low, but when the temperatures are low, the global ice volume is high. Finally, past greenhouse gases in ice cores can be used to work out the past atmospheric conditions because, well, basically it's like having a direct archive of the past climate in the ice, ready in the ice core. The air of the climate is trapped in a firn layer. A firn layer is the intermediate stage between fresh snow and glacial ice. When this snow is compacted, it turns to ice, where little gas bubbles form. The air bubbles are extracted by melting and crushing in a vacuum. This can provide a detailed record of greenhouse gases such as carbon dioxide and methane going back 650,000 years. And the graph I have given shows the methane and CO2 levels going back hundreds of thousands of years, and it compares to the ice volume. As you can see, the lower the CO2 and methane, the more ice there is due to lower temperatures, which can give the possibility of ice being on the planet. In conclusion, the evidence I have presented gives a strong possibility that ice ages have occurred. The physical factors show that ice has existed on the planet, for example, corries, which are easy to spot and are left behind by huge glaciers. The physical evidence also shows us that planet could have been covered in ice due to erratics being very far away from their original geologically correct position. The chemical evidence and ice cores can show that ice was around on Earth for a significant amount of time, allowing it to be an ice age. This is because from ice cores you can find the past air temperatures and climates, which show temperature drops, a lack of melting, so therefore a lack of melt layers, and we can show the concentrations of greenhouse gases. All of these can be used to work out the conditions of past environments and how long these conditions lasted, and can be used to show ice ages have occurred.